All right, ladies and gentlemen, good morning, good morning, good morning. We started off lesson 5 yesterday and we answered the questions and things like that. We got through most of it, but we didn't finish it all. So what I'm going to do is I'm going to do a quick review over what we started with lesson 5, and then you're going to finish it along with answering your problem set questions. All right, so let's go ahead and get started where we were at, all right? So in the morning, Harrison checked the temperature outside to find out that it was 12 degrees Fahrenheit. So this is what we need to remember, is that it is negative 12 degrees Fahrenheit outside. Later in the afternoon, the temperature rose 12 degrees Fahrenheit. So that means it started off at a negative 12 degrees Fahrenheit. The temperature rose 12 degrees Fahrenheit. So this is our expression, okay? This right here is our expression. It indicates that what the temperature was at the beginning and what the temperature rose by to get to the current temperature outside. And that's what our question is going to ask. What was the afternoon temperature? So negative 12 degrees Fahrenheit plus 12 degrees Fahrenheit gives us an afternoon temperature of 0 degrees Fahrenheit. Okay, so that's our answer. All right, this is just, remember, we're writing ourselves an expression to represent the information that is in the problem. You're not creating any new information. This is the information that's in the problem. You're using those numbers and only those numbers. All right. Now, for part B, numbers 1 through 4, it says rewrite the subtraction as adding the inverse or the following problems and find the sum. All right, so remember, we're adding the inverse. And if you remember, the word inverse means the opposite. So we are adding the opposite. Okay? So 2 minus 2 becomes 2 plus, and the opposite of a positive 2 becomes a negative 2. So 2 plus a negative 2 gives me 0. All right. Now, for number 2, we got a negative 4 minus a negative 4. So we have a negative 4, okay? Opposite, and then we're going to be doing the adding the inverse. So instead of a subtraction, we're going to have an addition. And then the opposite of a negative 4 is a positive 4. And a negative 4 plus 4, that's going to be 0. All right? The difference of 5 and 5. So we got the difference. We know it to be a subtraction problem. So this is where we're talking about subtraction. So we've got 5 minus 5. Okay? We're going to add the inverse. So we got 5 plus the opposite of a positive 5 is a negative 5. 5 plus a negative 5, that's going to be 0 again. Okay? Now we're doing it with variables. So we keep the first one, g, change the subtraction to addition. The opposite of a positive g is a negative g. G plus a negative g is going to be 0 again. Okay? Now, we have a very important question. What pattern do you notice in parts A and B? Okay? Parts A and B state that when you add a number and its opposite, the sum is 0. Okay? That is what the key thing here. That's what you need to know. The pattern is that when you add a number and its opposite, the sum is always 0. Okay? This is what we call the inverse property. Okay? This is the inverse property. So now let's take a look at D. Add or subtract. 16 plus 0, 16. 0, now remember, this is 0 plus a negative 7. Anything plus 0 is just going to be the original number. So this is a negative 7. Okay? Negative 4 plus 0 is a negative 4. 0 plus D is D. What patterns do you notice in parts I through 4? Numbers 1 through 4, okay? So, any number added to 0 will just be the number. Okay? This is what you call the identity property of 0. Okay? This is the identity property of 0. All right, now, this is where we started to leave off yesterday, okay? We left off here. So write the sum and then write an equivalent expression by collecting like terms and removing parentheses. So we're going to first write the sum, okay? So we get 2x plus a negative 2x plus 3. Okay, now it says write an equivalent expression by collecting like terms. Okay, well, 2x and a negative 2x are like terms. Well, based on our inverse property, 2x and a negative 2x are opposites, which means this is going to equal 0. Now we bring down the plus 3. All right, so this is the inverse property. And now this is going to be our identity property. 0 plus 3. Anything added to 0 is just going to be itself, so our answer is going to be 3. Okay? Now we got 2x minus 7 and the opposite of 2x. So 2x minus 7 plus the opposite of 2x, which is a negative 2x. Now I want to rearrange this so I get this negative 2x and this 2x next to each other. So I'm going to rewrite my problem. So it's 2x plus a negative 2x minus 7. This is just the commutative property of addition. Allows me to rearrange everything. Now this is, again, look, the inverse property is right here. The 2x plus a negative 2x. That's 0. 0 minus 7, that's going to be a negative 7. Okay, so again, our inverse property being used, and then our identity property being used. So negative 7 is our solution. All right, now the opposite of 5x minus 1 and 5x. So this is telling me the opposite of this. Okay, now this is a positive 5x minus 1, so now this is going to become a negative 5x minus 1 and 5x. Okay, now remember, a negative here is me when this is going to be a negative 1 right here. I'm going to take that negative 1 and I'm going to distribute it to every number on the inside. A negative 1 times a positive 5x is a negative 5x. Negative 1 times a negative 1 is going to be a positive 1 plus 5x. Again, I want to rewrite this so I get these two numbers right here next to each other. So 5x plus negative 5x plus 1. Still the same numbers. Negative 5x, positive 1. Nothing's changed, okay? I've just moved them around to each other. All right, so now 5x plus a negative 5x. Those are opposites. Opposites result in 0. 0 plus 1. This is identity property of 0. Whenever we add a number to 0, it's just the number. So our answer is 1. Okay? That is our answer, is just 1. All right. Okay, so let's take a look at example 2. All right, we got fractions here. All right, now, this is a very important set of rules. I want you to take a look at these, okay? 3/4 times 4/3, 4 times 1/4, 1/9 times 9, a negative 1/3 times a negative 3, a negative 6/5 times a negative 5/6. Okay? This is very interesting because these rules do not look like the same kind of rules that we normally see. Okay? These are a different set of rules. All right? We got a lot of fractions here, and we got a lot of a multiplication, but what I noticed something very important about this is that about these set of rules is that these numbers look to be like reciprocals. And if I'm true, when I multiply reciprocals, okay, if I multiply reciprocals, my product equals 1. Okay, another rule. This is another rule. So if I'm right, if these are all reciprocals of each other, okay, then that tells me that I should get, okay, that means I should get a product of 1. Okay, so 3 times 4 is 12. 4 times 3 is 12. 12 divided by 12 is 1. Okay, then I got to convert this to I got to convert 4 to a fraction. 4 times 1 is 4. 1 times 4 is 4. 4 divided by 4 is 1. So again, convert this to a fraction. 1 times 9 is 9. 9 times 1 is 9. 9 ninths is 1. All right, convert this to a fraction again. 1 times a negative 3 is a negative 3. Negative 3 times 1 is a negative 3. A negative 3 divided by a negative 3 is going to be a positive 1. Again, a negative times a negative is going to be a positive. So we're just going to go ahead and change these to a positive real quick. 6 times 5, that's 30. 5 times 6 is 30. 30 divided by 30 is 1. So yet again, these are reciprocals of each other because they all have an end result or a product of 1. So that's how we identify reciprocals when we're doing with multiplication. They have a product of 1. Okay? And we got a couple of problems here. Let's see. It says, let's take a look at 2 steps here. So we got to write the product and then write the expression in standard form by removing parentheses and combining like terms. Justify each step. All right, so I've got the multiplicative inverse of 1/5 and 2x minus 1/5. Okay, so the multiplicative inverse of 1/5 or the reciprocal. So if the reciprocal is just me flipping a number, 1/5, the reciprocal of that would be 5. Okay, and that would be 5 times 2x minus 1/5. Okay, well, 5 times 2x is going to be 10x. 5 times 1/5 is going to be 1, and then I just bring the subtraction down there. And that would be my answer, 10x minus 1, because I'm just using the distributive property here. Okay, so again, let me show you. 5 times 2x minus 5 times 1/5. Okay, now remember, a whole number and its reciprocal will look almost identical. The only difference is that whole number now becomes in the bottom of a fraction. So look over here. Whole number in its fraction. Look at the denominator there. That denominator matches the whole number on the outside. Okay, and there is a numerator of 1. This tells me that these are reciprocals, that these are multiplicative inverses of each other. So because of that, I know that 5 times 1/5 is going to be 1. 5 times 2x is going to be 10x. And then I'm going to get a subtraction. Okay? Now look at B, the multiplicative inverse of 2. So here's 2. I want to find the multiplicative inverse. Okay? Now to find the multiplicative inverse of a whole number, it's actually quite simple. You take the whole number, write it as a denominator in the fraction, and then write 1 in the numerator. 1/2 is the multiplicative inverse of 2. So now I get 1/2 times 2x plus 4. All right, so look again, there's 1/2 times 2. Well, we already know 2 and 1 are multiplicative inverses. So 1/2 of 2 is just going to be 1, or x. 1/2 of 4 is going to be 2, so this is x plus 2, and that's my answer. Okay, so that's the multiplicative inverses. All right, I know it's going to take you some practice, so do not feel rushed or feel out of place if you're going to still struggle on it a little bit, okay? It's not the end of the world, all right? So this is what I want you to do today for your classwork assignment, okay? I want you to, do numbers 2, A, B, number 3, C, and D, and then for number 4, okay, number 4, write the expression in standard form. I want you to do A, C, and E. Okay? That's what I want you to do. Now, I'm going to do, this is all going to be part of a formative, so we're going to upload all this, and you'll be good to go, all right? But that's going to be the end of today's lesson, so thank y'all.